Welcome back to Robominions.in AI interview preparation app. The topic of this video is counting degree 2 nodes in binary tree. So before tracing this code, I would request you to watch this video on a bigger screen like a laptop, or please make your mobile phone screen full size. Okay, because on a small screen the code may not be visible for you. So strongly suggest you to watch it on a laptop, so that will be really helpful. And another recommendation is, like, do not forget to download the app Robominions.in AI interview preparation app. The tracing I'm doing is in the app, so you can do back and next tracing of the code yourself. And once you have watched the video and once you know how the code is working, right, then by using back and next button you can revise the concepts whenever you want, uh, like before going to an interview or before writing an exam, gate exam, or semester end exams. Whenever you want, you can revise all the concepts by just clicking back and next button. You get clear picture of what exactly is happening at every stage of the code. So, and yeah, to download this app, you have to visit the website robominions.in. Click on download latest version of the app. Uh, if you have a Windows laptop, click on download for Windows OS. So this app will help you tracing the code. So coming back to the tracing of counting degree 2 nodes in a binary tree. So first we have hash include stdi.h, then we have hash include stdlib.h, then we have hash include binary tree create.h. This header file code will create the binary tree with the default values. The explanation of this part of the code is already done in DSA41 creating binary tree. Please watch that video if you haven't yet watched, and then you can come back to this video. Okay, so then we go to int main. So remember, you have to the tracing of the code is done using this arrow mark. Okay, so then we go to node pointer root equal to create binary tree. So create binary tree function is present in this header file hash include binary tree create.h. So this header file has the function create binary tree. So this will generate the binary tree and return the root address, root node address. So in this binary tree, you can see that the node with the value 11 is a degree 2 node because it has two nodes connected to it. So it is degree 2. These this one is a degree 2 node, 12 is a degree 2 node, 10 is a degree 2 node, because both because the node has both left child and right child. So you have to follow the convention: left child, data value, right child, and the node address, that is address of the node itself. So if the node has both the child, then it is a degree 2 node. If the node has only one child, it is a degree 1 node. If the node has so here, if the node has no child, then it's a leaf node or a 0 degree node. Okay, so coming back, so we have created the binary tree. Now we count the number of degree 2 nodes in this binary tree. So we call the function count degree 2 node. We pass the root address. So hash 100 will be passed. The root is pointing to this node. Okay, so we have ITR receiving, the ITR pointer is created, it receives the address hash 100. Then we have left count equal to 0, right count equal to 0. Then we have ITR not equal to null. ITR is pointing to this node, it is a valid node, it is not equal to null, it is true. Then we go to the ITR of left. ITR of left is hash 200, we go to this node. So we recursively called again count degree 2 node on this node. So let's see, left count equal to 0, right count equal to 0, ITR not equal to null. This node is not equal to null, it is true. Again it goes to left of, again it calls the count degree 2 node ITR of left. ITR of left is hash 400, that is this node. Now again we go and recursively call the count degree 2 node has been called. Then we go to ITR not equal to null, this node is not equal to null, true. Now again we call the count degree 2 node recursively with ITR left. ITR left now is null. I repeat, ITR left, because ITR of left is null. So it is null is passed. So count degree 2 node has null now in the ITR. So it comes ITR not equal to null. No, it is equal to null. So it returns 0. 0 is returned as a left count for this node. Then it checks the right count. So it goes to the right. So now ITR of right. ITR of right is also null. So count degree 2 node, it goes to count degree 2 node. Left count equal to 0, right count is equal to 0. ITR is null. You see, ITR of we have, because we have passed ITR of right null. So null has been passed. That returns 0. So now left count is 0, right count is 0 for this node. Now it comes to the if statement. So if statement for this node, we have whether ITR of left and ITR of right. So since both are null, so if any of that is null, then we don't consider it as degree 2, because if one is null and one is not null, then it would have been degree 1 node, right? So if only if both the child exist, both the child of the node exist, only then it is considered as degree 2 node. Okay. Now since this is 0, even this is 0, this is false. So comes to the else part. Now left count plus right count is 0 plus 0, because for this node there are no children. So left count is also 0, right count is also 0, because we know we got the 0, right? Left count equal to 0, right count is 0. So this is returned. This value is returned for this node. So it is returned left count equal to 0. So you can see this node has been marked red because it doesn't have uh, any childrens. Okay, this node doesn't have any childrens. Then we have gone back to this node. From here we go to the next, that is right count. We go to the ITR of right. So ITR of right is hash 500. So we gone to this node. Now we go inside. For this node we have ITR not equal to null. For this node ITR not equal to null, true. Then we have left count, we have ITR of left. ITR of left for this node is null. So that is passed, null is passed. So count degree 2 node null. Then we have null not equal to null is false. It returns 0. So for this node it returns 0. Then we have right count equal to count degree 2 node of ITR of right. ITR of right is also null. So it again goes to count degree 2 node of null. So null not equal to null is false. Even that returns 0. So now we have left count equal to 0, right count equal to 0. Then in the if condition for this node, we have both null. 0 and 0 is false. It goes to the else part and returns left count 0 plus right count 0. So that is 0 is returned to the for this node. Okay, we have 0. Now we have reached this node. I just want to repeat, both this node left and right had 0 children. We have already marked it as red. So counting for these two nodes has been done. Now we are here. Now we have recursively returned, because there is a recursive function, right? We have returned to this node now. So count. So right count 0, because we are counting degree 2 nodes. So we don't have any degree 2 nodes in the children, right? So the count is 0 for this node, the count is 0 for this node, because both are not degree 2 nodes. So both is left count and right count is 0. Now it goes the if condition for this node. So in this node the if condition says, yeah, both the node exist, right? The childrens are there. So this condition passes. It goes inside the if condition. So in the if condition, we count, left count is 0, correct? Right count is 0. I just repeated, right? 0. But plus 1, because this node itself is a degree 2 node, right? It has 2 children. So it is a degree. So we are counting itself. So that will be turning green now. So, but where does it return? It returns to this node, right? So it returns as a left count for this node. So left count of this node is 1 because that is the green we are counting. So it is 1. Now we go from, for this node we go to right side now. So you can see we go to the right, ITR right. So ITR right, we have gone to this node now. Hope it's clear. Now it goes inside. Now we call count degree 2 node on ITR of right. So we call count degree 2 node function again, recursive call. Goes there. Then we have left count equal to 0, right count equal to 0, ITR not equal to null. This is a valid node. It is not equal to null. True. It goes to the left, ITR of left. You can see ITR of left, count degree 2 node. So we have gone to ITR of left of this node. Now even this node is not it is a valid node. Again we have ITR not equal to null. True. This node is not equal to null. True. Then we do a left count equal to again ITR of left. For this node, ITR of left is null, right? See, I'm just pointing it out. It is null. Keep observing. Then we are passing null here now. Passing null. Count degree 2 node. Again left count equal to 0, right count equal to 0. Null. So ITR is null now. You can see here it is null. So null not equal to null is false. So return 0. So return 0 to the left count. Then we go to the right side of this node. That is node 15. We go to the right side. ITR of right is also null. You can see ITR of right is null. So it goes to again count degree 2 node is recursively called. So null not equal to null becomes false. ITR not equal to null is false. Comes return 0. So count has been returned 0. Now we go to the if condition for this node. So we go to the if condition. Okay, you can see we have gone to the if condition. ITR of left is null. ITR of right is null. 0 and 0 because both are false. So false is 0, right? So this turns false. So that will return. So that will go to the else part and return left count plus right count. That is both are 0. So this node is a childless node. So it doesn't have any kind of degree. So it's a 0 degree. So the 0 is returned. That is returned to which node? This node. So recursive function of this node. So it's returned to that. So for this node left count we have 0 because in left side we don't have any degree 2 nodes. Then we go from this node, we go to the right side, hash 700. You can see we have gone to the right side. So ITR of right will be hash 700. So that is passed to the count degree 2 node function. So you see count degree 2 node is called with the hash 700 pointing. Then we go to ITR not equal to null is true because this node is a valid node. It goes inside the if condition. You can see it goes inside the if condition. Now for left count we call count degree 2 node again recursively with ITR of left. ITR of left for this node is null. You see left child is null, right, for this node. So it is null. Null is passed to the function. Again left count equal to 0, right count equal to 0. ITR not equal to null is false because it is equal to null. So it goes to the return 0. So 0 is returned for this node. Left count is 0. Now it goes and checks the right side. So right count. For that it does ITR of right. ITR of right is null. So it goes to the count degree 2 node function again. Left count equal to 0, right count equal to 0. ITR not equal to null is false because it is equal to null. So left count, so it doesn't go inside the if condition. It returns 0. So 0 is returned as the right count for this node. Now it goes to the if condition for this node. In the if condition, ITR of left is null, ITR of right is null. So this condition becomes false and it goes to the else part. Goes to the else part and returns both left count plus right count as 0 for this node. So this 0 is returned back to this node's recursive function. If I click next, you see the right count for this node is also 0. Now it goes to the if condition for this node. In the if condition, we have left child, we have right child. ITR of left, ITR of right is true. So it goes inside the return, inside the if condition, it returns left count for this node is 0, right count is 0, because these red nodes are not degree 2 nodes. That is the reason it is 0. So left count is 0, right count is 0, plus 1. So 1 is added for this node. The reason is this node itself is a degree 2 node, right? So that is why it is added with 1. So counting the node itself, but say in its children's there are no degree 2 nodes. So that is why you collect the count from the bottom. You keep on collecting counts, and then you collect count, add all the counts and then return. I hope you are understanding. It trickles down, counts all the degree 2 nodes, bring it back up, and then give it out. Okay, so that is what is happening for this node. Now we have one degree 2 node, so this will turn green, and then it returns that count to the main node. So it returns, see, it has turned green. This count 1 has been returned to the main. So now we check the main node, that is root node. So it has left child, it has right child, so the if condition has passed. So it goes inside the if condition. Now it returns left count. For this node, the left count is 1. There is one green here, there is one green here in the right side too. So left count plus right count plus 1, because the node itself is a degree 2 node, right? So plus 1 is done. So because it is past the if condition, that is the reason we are adding 1. I hope you remember. We don't add anything for this is because it has failed the condition. This if condition determines whether there are left or right childs. So if condition says you need both left and right child for the node to be degree 2 node. I hope you keep that in mind. Now it is returning 1 plus 1 plus 1, 3. So count of degree 2 nodes in the tree is 3. See, 3 green boxes are there, so those are the degree 2 nodes. Then it returns from the main function. The time complexity, as we are going through each of the nodes to find out the degree 2 nodes, the time complexity is order of n. Okay, if you want to revise the concepts and you want to trace it yourself step by step, download the app robominions.in AI interview preparation app, and you can use the back and next button to check the individual steps in the code. Okay, you can trace the code yourself, and this code is available in the code button. If you just click the code button, you have access to the code. You can run it on any online or offline compilers, log yourself, and try to debug the code. Okay, thank you for watching. See you soon. Bye. Signing up, Dhananjai Sharma,
founder of Robominions.in. Don't forget to subscribe to the YouTube channel, share with your friends and family. Visit Robominions.in website, crack your toughest coding questions and tech interviews by downloading latest version of the app, and make your coding easy. Thank you for watching this video. Bye.